Assalamualaikum guys, welcome back to the channel. So guys, inshallah today we will cover about our first data type, our first data structure that is called the linked list. Okay. In last video we went over to we discussed data structures. Okay, what is the data structures and why there is a need for the data structures. So today inshallah we will cover about some more data structures. Okay, and its types. So this is the outline for our today's agenda. I'm just moving one by one to the next one to give you the sense. Okay. So first of all, we have static versus dynamic data structure. What are the both ones? Static means that an array is a structure of the fixed size. Okay, that each element will be efficiently stored in this one. Advantage is that these are the some theoretical things. Static means static as a word itself says. Static means fixed. Okay. What is the meaning for fixed one? Fixed one means once you have defined the number of elements, you will never change. Okay. Once you define the size, you will never change in the program. That is called the fixed data structures. And what are the dynamic which you can grow or shrink according to the demand? Okay, which you can grow on or shrink according to your demand or according to your requirement in the program. Static includes, let's say, array. This is a one classical example for the static data structures. And for the dynamic, we have a very the modified form for this array one, which is called the array list. This is a modified form for the array. Okay, so static means that once we define, okay, we never change. Okay, once we define the number of or once we define the size, we never change. But in the dynamic we can grow or shrink according to our requirement. Okay, so an array is the structure of the fixed size data record that each element can be efficiently located by indexes. Array concept, guys, if you remember, array contains the indexes. This is how we define an array. Okay, array contain the list is array contain the indexes. This is a zero index, this is a one index, this is a two index, same like for the other ones. Okay, advantages of contiguously allocated array includes constant time access given the index. Array consists purely of data, so no space will be wasted with other links or formatting information. We remember array always store the same metadata. Okay, this is a very important difference between two. If someone says why we use the array, okay, or array allows the different data types, you say no. Array only contains the same data structure. You cannot store in array with integer with float number. Let's say you are storing 1 and you are storing 0.1. This is not allowed. You only store either the integer or you store either the float. Okay, array is basically consist of a, what is it called, array consists of same data type. Okay, array's purpose is to contain the same data type. Okay, so this is how your static versus dynamic data structures. Next we are moving, that is what we call the array list. Array, as we discussed, that what is array. Array means once we define the number of sizes, we never change. Let's say we defined an array for 5. Okay, we have defined the size for the 5. Let's say 5 element can be stored in this array. Let's say array have 1 2 3 4 5 4 5 elements I have defined. We defined here that array contains only uh, five records, or you say 5 lists. Okay, so once we define the number of size, we never change in the program. Okay, this is the big disadvantages of array. Okay, let's say if you have defined the 5 size and you store and your requirement is, let's say when you use the things and when you finish your program, you think that you only require the 3 spaces. It means that spaces will be wasted. Okay, you need 3 spaces, these 2 will be wasted because you never change now size. This is a big advantage, is that a lot of memory will be wasted. Okay, so array list is the modified form. What is the array list? Array list means that you can grow or shrink the size of an array. Okay, of an array list. Okay, according to your, let's say in start you define the five array size is 5, but when you are coding, okay, you think so that you only require three. Okay, so it means you can change the size. This is the difference between the array and the array list. So array list is basically self-resizing array. Okay, it will be resized. In other words, a dynamic array. Dynamic means that you can grow or shrink the size according to your requirement. This means that this data structures can grow as much as it needs as compared to the classical static array, which cannot because it has a predefined maximum size. What it is saying, it's saying that in simple array, once you define the number of size, you never change throughout the program. But in the array list, the big advantages of array list is that if you define the number of size three, but you think that in last you need the five size, so you can change the size. So this is how you can grow or shrink according to your requirement. But array will not allow this one to change the size. This is not allowed in the array. That's why we use this array list. This is a modified form of the array. Okay, the need for this data structure is most obvious when you have urge to store items without knowing that how much space you will need in advance. Let's say I already explained that you are not familiar that how much amount of space you require to store this one. Let's say you roughly guess that 20, let's say, MB space is required. Okay, let's say you suppose, but when you executed the things, your guess was wrong. Let's say you define the 20 MB size in array. Okay, you think so that the space you required is 20 MB, but when you executed the things, your guess was supposed wrong. Okay, and the amount of space is required, let's say 60 MB. So if you define in an array, you cannot change this size. You cannot change this size. Okay, you cannot change this space. But let's suppose if you are using the array list, you can change the space. Okay, you can change the space. Okay, and adjust according to your demand. Okay, or you can grow or you can shrink. Okay, let's say you define 30 MB in start, but in last you only need 5 MB, so you can shrink the size as well in array list, but in array this is not allowed. So this is the differences between the array and the array list. This is the array list example. Let's say these are the digits, let's say 24, 69, 7, 26, and here 000. Let's say now we need to add something. These three spaces are empty. Okay, and here these indexes, let's say 0, 1, 2, 3, 4 are fixed. Okay, but we have the total size that is called the 7, that we can store 7 in it. Okay, so what we need to do, if you want to remove someone, okay, or you say, yeah, if you want to remove someone, let's say you want to remove this 6, so what you need to do, you add other elements. Okay, you can remove this one. Okay, the rest will take this place. Okay, 91, 91, okay, 97, and the now last will be the 0. Last space will be the empty. Okay, because this element you already removed, so this next one will take this place, this will take this place, and this will take this place, and same like this last will left. Same like you can resize the elements as well. Okay, you can add the elements or you can remove the elements in array list. It is very easy, but in array, when you are removing something, it is very difficult. Okay, because as I told you that array contains indexes. Let's say you are removing, let's say this is the elements including in the array, and you have this index 0, this index 1, 2, 3. Let's say you want to remove this index 1. This, once you define remove this index 1, in this place now you cannot store another element. Okay, you cannot store element, this space now will be wasted. But in the array list you can move the elements here. Okay, and you utilize this space. Okay, so in the array it is not allowed. So next thing, if I move to, that is what we call, yeah, arrays limitation. Now arrays, we know very well, arrays are simple and fast because it contains the same data type. Okay, if we have the same data type, then obviously that thing will be simple and fast. So arrays are simple and fast, but must specify size. This is the big disadvantages of array, that you must specify the size at the construction time. It means at the declaration time you must specify the size, that what size you require of that array. Okay, According to the Murphy's law, that construct an array with the n elements and choice with the largest collection, let's say more specific. This is simple says that array's limitation that it is simple and fast. These are the advantages. But the big disadvantages or big disadvantage that you must specify the size, okay, at the time of declaring. Okay, once you define the five size, it will never change. This is a big disadvantage that you never change the size of the arrays. Why? In array list or in linked list or in view stack, okay, you can change. Okay, you can change the size. So this is a big limitation of arrays. So let me move next. Yeah, then what will be the result? Then array list is also modified form of array, but in today's we are using the linked list. Therefore, there is a need of the structure that dynamically allocates spaces for each element as needed. Okay, that is what we call the linked list. Linked list is basically a data structure which can efficiently store. Okay, linked list basically consists of the nodes. Okay, it consists of nodes. Linked list consists of nodes. Okay, the reason for using linked list is that in array memory size is fixed. Okay, while on the other hand, linked list size is changeable. You can change the sizes as well. Okay, and very big advantage is that insertion and deletion is easy as compared to array. Okay, if you are adding or removing something in an array, it will be very difficult for you. But in linked list, it's very easy because linked list contains the addresses. Okay, every linked list is combined and connected with the addresses. Okay, and pointer is used for address storing. Okay, pointers is a big advantages of the linked list is that it contains the pointers. Okay, pointers actually store the address for the next number which is stored in the linked list, which is stored in the node. So these are big advantages of the linked list. So we are now moving to the linked list one by one. So linked list. Now linked list, basically, be remember a linked list is a linear data structure, okay? And with the elements are not stored at contiguous memory location, that it is not guaranteed that, let's suppose when is stored here, one is stored here and two will be stored here. No, maybe here three is stored, here four, let's say here seven, and here then two is stored. Okay, so it is not necessary that each elements are not stored. Okay, in which the elements are not stored at their contiguous memory locations. Okay, the elements in the linked list are linked using pointers. Okay, as I told you, pointers, why we use a pointers, because pointers contain the addresses. Nodes means that this is how linked list works. This is how linked list connects with each other. Okay, and we shall cover in the next things that how linked list contains the things, the data. Okay, linked list contains the data and the next. This next is basically represents pointer. This data part contains your number, and this next one actually contains the addresses for this next data. Same like this next contains the address for next data. Okay, so pointers entity that point to represent the element. In simple word, a linked list consists of the nodes. These are basically the nodes. Okay, linked list consists of the nodes where each node contains a data field and the reference link, that is what we call the pointer to the next node in the list. Okay, so this is how your linked list, the proper definition for the linked list. Yeah, linked list representation. Linked list can be visualized as a chain of the nodes where each node points to the next one. This is how your linked list looks like. So I'm drawing it here. Let's say here this part is called the data part. I'm just representing data, and here this part is called the pointer. Pointer contains the addresses for the next one. Same like here, what is it called? Here it contains the data, and here it contains the pointer. Okay, same like this, it is consist of the chains. Okay, so as per above illustration, following are the important points to be considered. As you see, the picture is clear. This is, we remember there is one head pointers in the start. Okay, head pointers in the start. This is a head pointer which represents the linked list. Then we have here data, then here we have the next on the pointer. Okay, next to the pointer, same like we have the data and the next, and in last when your node is end, then we have, I think, null. Yes, null will be used. Okay, linked list contains link elements called the first. Each links carries the data fields and a link called next. Each link is linked with its next link, uses its next link, and the last link comes. These are all things that how your linked list is made of. Okay, how your chain works. So this is all about that. So if I want to move next, we have, yeah, working of linked list. How your linked list works. Okay, linked list consists of the nodes where each node contains a data field. This one, okay, data field, and to the next node. As I told you, this is, let's suppose, your linked list. This contains the data part. Here, let's say number. I am just writing a number. Let's say here 10 is a number, and this part contains the address for that, for the next number, next number. Okay, it contains that dash. This is what we call pointer. Here what we call the next as well. Okay, so node link object e node consists of the two parts, data and link to the next one. Next is actually contains the address for that one. Okay, next, this points to the next node in the linked list. Since there are not stored, they are not stored in the continuous memory location. Okay, why we use the pointer? The reason is that because we are not sure that the next element is stored in the contiguous position or not. Let's say that 2 is not stored in the contiguous position. Let's say in this linked list we stored, let's say 1, and it contains, let's say it is not containing address. Let's say 2 is stored here. Okay, 2 is stored here, and here in between we have 3, in here we have 5, and here we have. So if we use the pointers, then it is very clear to us and very understandable to us that if we give the address for that one in this in this pointer, then it's very easy for us to find the two element that where it is located or where it is stored in the map. So this is how your pointers helps you to find out that where the element is stored in the contiguous, where the element is stored in the map. So this is in this way that how your linked list helps you. Okay, or pointers, sorry, helps you. Next thing we have, that is what we call operation on linked list. Same like in array when we are adding or insertion or deletion. Okay, let's say adding. This is called the head pointer. First of all, we have the head. Okay, we have the head node. It contains the 24. As I told you, this contains the data part and this contains the pointer. Same like it points to the next one. This pointer contains the address for this number. Okay, this is the data part, this is the same pointer address part. Same like this pointer now contains the address for this one, as head node as head node doesn't contain any address. You remember, head doesn't contain any address. Okay, so it is contained same like they are, as you see, interconnected with each other. Okay, now we move to the next one, and we need some more clarification on it. So insert, how you insert a node. Let's say you have this one and you want to insert a 7 in it. Okay, you want to insert 7 in this one. 7, it, let's say, not included. So how you do this? Okay, I'm just drawing for you. Let's say this part contains 24 and 24 contains some address. Okay, let's say here I'm just using the dot, it means address. Same like I have the next number that is called, let's say I'm taking 13, and it also contains some address. Now I want to add this 7. So how I want to add this 7? This is also present. Sorry, I want to add 104. So how we need to add? Just put 104 here and give the address to that one. Let's say now 30. This pointer contains the address for this one. Once you add 104, then connect with the last one, with the 7. Now this 7 contains no more address because here your linked list has ended. So this is how you add 104 in this chain. Just assign that number, just assign the address of that number to the pointer. So pointer automatically indicates that where you store 104 in memory. So this is insertion and deletion. I told you before, it's very easy in linked list, okay, as compared to array. So we need to now go next one. Yeah, remove that. How you remove the elements. Let's suppose you want to remove this 69. It's very easy. I'm just drawing it here a little bit for you so you people understand. Let's say here this section contains 24 and this is the pointer address, and we have this 69 here. I will draw this again when I remove. This is 69, and here let's say it contains the 7. Okay, All right, and this one contain no address because here our pointer has closed. This is called the head one. Okay, the first node is called the head one. Okay, or it contains head one also. No, this one. This is how it's connect. Okay, this is called the head one. This is not. Okay, so I now I want to remove this 69. How I can remove? Same like I use the head as it is 24. And now what I need to do, I just assign the address for 7 in it because I want to remove the 69. So here it contains nothing. So what I just remove this and this pointer. Now I gave the address, I gave the address for this pointer of 7. Okay, I assigned the address of this 7 to this pointer so that it are now it's works. So now this 69 has successfully removed from this linked list. So this is how this linked list works. Then we have, if I want to post some in tab, okay, here one. We have some operations on the linked list. We have, you can also traverse a list, okay, append a new node, prepend, okay, inserting, everything is very easy. Okay, we have this one, data one, this is a simple head, everything is very easy. Okay, you just have to remember that the linked list consists of the data and the pointer part. Pointer contains the addresses for the next number. Okay, and data contains the data section. Simple. So this picture actually represents that one. Then we have, yeah, these are some practice questions which we need to follow that how we do the thing. Okay, so things are very easy. Let's say this linked list is 10, 15, 20. I'm just drawing it here. If it, yeah, I'm just trying it. It contains that linked list contains 10, 15, 20, and 25. And we need to add 5 in front. In front means that we want to add the 5 in start of this linked list. So how we add? So as we know, it says that add 5 in front of that one. So I'm starting from here. So 5 I added in front, and now 5 contains the address for the 10. This is now 10, and now 10 contains the addresses for like other ones, 15, and 15 contains the address for the 20th one, and 20th contains the address for the 25th one. And in 25 there is no address, so here we call the null or no address. Okay, so this is how you insert the 5 in front of these numbers 1, 10, 15, 20, and 25. Same like if the given link this array is 5, 10, 15, 20, and 25, and we want an item 30 in the end. So what we need to do, you just add here. Now this is not null because the next thing is present, so you just add 30 here. Now 30 section is blank because it doesn't contain any address. So here this is called the null one. Okay, it contains null address, no address. Okay, same like if the given link address is 5, 10, 15, 20, and 25, and we need to add 30 after 15, it means that we need to add 30 here. So what we need to do, just break this one and now make with this 30 here. Now once you define 30 here, now assign this pointer address to this one instead for this one. Okay, just remove from here. Now first give address to this one. Now this pointer contains the address for this 20. So this is how you connect the list. Sorry, you connect the node between 15. How linked list works now? 10, 5, 10, 15, then 30, then 20, then this 15, and then this 20. So this is how your linked list works, how you add or insert these things. So guys, I hope so these things understand it to you that how the linked list works. Okay, linked list versus arrays, advantages of linked list over arrays, dynamic size, and ways of insertion and deletion. These are the two major flaws in the array. That's why we considered this one. Disadvantages of linked list: using random access is not allowed. We obviously, there's some disadvantages. Every we remember the data structure which you are using, every data structure has its own advantages or disadvantages. Like array, we have some disadvantages, but we have advantages as well. That it is simple and it's fast for execution. Same like if I talk about the linked list, that linked list can sorry, arrays advantages that sorry, yeah, linked list advantages like dynamic size, you can grow and shrink according to your demand, and ease of insertion. Insertion and deletion is very easy as compared to arrays. While on the other hand, if I talk about the disadvantages of linked list is that random access is not allowed. Okay, extra memory space for the pointers. Obviously, node or linked list consists of the data plus the no plus the pointers. So you need to give extra space for the pointer as well. No cache friendly. No cache friendly means that elements are not stored in the continuous position. Let's say one is stored in start, and let's say two stored in is stored in last one. So this is the how your random access or contiguous locations are not present. Okay, and linked list as compared to array, while array contains stores element in the contiguous position. Okay, you yeah, that's fine for all. So this is how your linked list. Okay, then we have some type of linked list, singly, doubly, circle, but we discuss these things in the next lecture. So that's all about, we discussed about the linked list, that what are the limitations for the array, then why we use the linked list, everything I explained, and how you insert and delete the linked list. So guys, that's all related to the linked list data structures. Very, very easy, guys. You just try to keep the concept in your mind that how linked list consists of. Guys, meet you in next video. If you like this video, kindly do like, subscribe, and share. Meet you next video. Take care.